Hello and welcome to the 12th video of this video series. Today I want to talk about arithmetic operators. In nearly every programming language you can use the basic arithmetic operators to perform arithmetic operations between two values. To do that, you basically just need to write the mathematical operators and the values in the same way like you would write them in a normal mathematical context. Use the plus sign for addition, the minus sign for subtraction, the asterisk for multiplication, and the slash for division. You can also perform an operation called modulo, and for those of you who don't know what modulo means, modulo is basically just an operation that returns you the remainder of a division. To use the modulo operation, just write a % symbol between your two values. You can also just use the round brackets like you would use them in the mathematical context. To give you an example, let's multiply 5 by 1 plus 4, but 1 plus 4 we will write in round brackets, so basically we are multiplying 5 by 5. That means the result should be 25. And if we execute this, you can see that the result is 25. You can also do exactly the same thing with variables. So for example, let's create a variable called number and let's assign the value 5 to it. And if we now change this line of code and multiply number times 1 plus 4 in the round brackets, you can see that the result is still the same. Okay, let me show you another example that shows you how important the correct data type is. For example, if we create another variable called number2, which is an integer as well, and assign the value 3 to it, and if we now divide number2 by number, you can see that the result will be 0. And that is because the result of an operation between two integers will be an integer as well. And that means there will be no floating point value, and that's why the result is 0. If I change the data type of one of the variables to float now, then the result will be a float as well. Okay, so let's change the data type of number to float and let's run this again. And as you can see, the result will be 0.6, so this is the correct result now. Let's try out the modulo operation and the subtraction now. For the subtraction, let's subtract number by itself, so number subtracted by number. And for the modulo operation, let's use 15 modulo 4. And as you can see, we get 0 for the first operation, which is correct because number subtracted by number is exactly 0. And for the second operation, we get 3. And that's because the 4 fits 3 times inside the 15. But careful now, the 3 for the 3 times that the 4 fits inside the 15 is not why the result is 3. Now that the 4 fitted 3 times inside the 15, we have 3 times 4, which is 12. Now 12 to 15 is 3, so that's the result. So we have 3 left to 15, and that is the result that we see here. But what happens to the variable's value if you do an operation with the variable? For example, if you write number times 2, number would still be 5. Number would not be 10. Only for the moment that you write number times 2, it will calculate the result, and for example, if you put that term inside a debug log, then it will console log this result, yes, but this result will not be saved inside the variable. So after this calculation, number will still be 5. Okay, so if that's not saving the result inside the variable, let me show you then how to save a result inside the variable. For example, if we want to calculate number times 2, so if we want our number to be 10 afterwards, just write number equals to number times 2. And now after this operation, so after this line of code, if we would debug log number, then number would be 10. What we could also do is, for example, write number 2 equals number times 2. So for example, we can also save a value inside number 2 that is calculated with the variable number and not the variable number 2. Okay, so let's execute this and check out the results. So if we debug log now number and debug log number 2, after the lines of code where we change the value of number and number 2 and execute the script, you can see that both of the variables have the value 10 now. Okay, so that's good. Now we can change our variables values with arithmetic operations, or we can save the results of a mathematical term inside a variable. But actually for the first thing that we did here, where we multiplied our variable number times 2, there is a way to do that much faster. Because actually this, what we wrote here, is the same as if I would write number asterisk equals 2. Because this is exactly the same. Asterisk equals just means equals to number times and then the value that you write behind the asterisk equals. The same is also possible with the other arithmetic operations that I showed you before. So we can also write plus equals, minus equals, asterisk equals like I already showed you, slash equals, or percentage equals. So for example, if I had a variable that has the value 5, for example number, and I would write number plus equals 10, then it would have the value 15 afterwards. Okay, so let's do a quick cut here, and as you can see now, I have written down 5 examples for this, one example for each arithmetic operator, and if we execute this, you can see the results, and you can see that it works exactly like if we wrote it in the other way that I showed you before. Now the last thing regarding arithmetic operators that I want to show you now are the increment and the decrement operators. The increment operator is just an operator that increments your value of your variable by 1. And the decrement operator is an operator that decrements it by 1. So that means if you have 5 and you increment your variable, then you have 6. And if you have 5 and you decrement your variable, then you have 4. To increment your variable, just write your variable name followed by 2 plus symbols, or you can write the 2 plus symbols before your variable name. But there is a small difference and I will explain that now. If you write the 2 plus symbols behind your variable's name, that is called postfix increment operator, and if you write them in front of your variable's name, that is called prefix increment operator. The difference between these two is what it returns. So basically, if you write this term in a single line and continue calculation in the next lines afterwards, then it doesn't matter which of these two terms you use. But if you want to continue calculation directly with this term, for example, if you want to put this term inside a method call as a parameter, then it depends on which of those two you use. And that is because the postfix increment operator will return the value before the operation, and the prefix increment operator will return the value after the operation. That means, to give you an example, if you write number plus plus inside the debug log call and number has the value 5 before, then the debug log call will print 5 to the console, even though number will be 6 afterwards. So if you write a second debug log call below that, where you debug log number again, this will print 6, but the debug log call before will print 5. However, if you write plus plus number inside the first debug log call, then it will already print 6. And that is essentially the same for the decrement operator, so you can write minus minus number or number minus minus. And if you write number minus minus, then it will still write 5 to the console, even though number will be 4 afterwards. But if you write minus minus number, then it will already directly write number as 4 to the console, so it will print 4 to the console. Okay, so let's try that out one time. So let's print number minus minus to the console, and afterwards let's print number to the console. Okay, and if we execute this, you can see that the result is exactly like we predicted it. Okay, now that we have finished to talk about the basic arithmetic operations, let's talk about the Bitshift operations. For those of you who have already experience in binary, that should be no problem. If you have no experience with binary at all, I recommend you to watch a few videos about binary before you watch this part of the video. So as many of you maybe already know, if you want to write a value in hexadecimal format, you need to start with 0x followed by the value in hexadecimal format. So as an example, let's declare an integer value and give it the value 0xf, that's 15, and if we debug log this and start, you can see in the console that 15 got printed to the console. Okay, that's how you write a hexadecimal literal. However, if you want to write a binary literal, you need to start with 0b, and after that you write your binary value. So as an example, let's save the value 16 inside our variable now. So let's change this to 0b, and then we will write 0, 0, 0, 1, and an underscore, because after 4 bits you can do an underscore, and then we will write 4 zeros, and that's it. So now we have saved the value 16 inside our variable. Let's log this, and as you can see in the console, the value 16 got printed. So as I said, you can do an underscore, which means you don't need to do one, but as you can see, it's way easier to read this if you have the underscore after 4 bits. Okay, so let's start with the left shift operator. The left shift operator will shift all bits to the left side, and you can define how far the bits should be shifted. Okay, to do that, I want to change our example a bit, so it's a bit more obvious. So let's change the last bit to a 1 instead of a 0. Okay, and now let's use the Bitshift operator. And to do that, you will write 2 lesser signs, followed by the value or by the amount that you want to shift all bits to the left side. So how far do we want to shift them? Let's say 2, and let's start this and see the result. And while checking out the example, don't get confused here, because you may think there is a 0 missing, and this is correct, but all leading zeros will be removed until it's hitting the first one, because all these zeros have no effect on the number whatsoever. And what you can also see is that after our 1 at the end of our binary literal was shifted 2 bits to the left side, these 2 bits were filled up with zeros. And also, even though it did not happen in this example, it is important to mention that all high order bits will be discarded if they are outside the range of the result type after you bit shift. So as an example, as you already know, an integer has 32 bits, and if you have a 32-bit long binary literal, and the first bit is a 1, and you shift a few bits, then this 1 will be discarded because it's outside of your 32-bit range. Okay, the next thing that I want to show you is the right shift operator, which is basically doing exactly the same like the left shift operator, but the right shift operator is shifting all the bits to the right side. For this operator, it depends on the data type if the new bits will be set to 0 or to 1. If the data type is unsigned, then all new bits will be set to 0, exactly like with the left shift operator. If the data type is signed, however, then all new bits will be set to the value of the sign bit. However, if you don't want this behavior and always want your empty bit positions to be set to 0, independent if your data type is signed or unsigned, then you can use the unsigned right shift operator. This operator will always set the new bit positions to 0. To use the unsigned right shift operator, just use 3 greater than symbols instead of 2 greater than symbols. However, at the point in time when this video comes out, you most likely still need to use unsigned int if you want your new bits to be filled up with zeros, and that's because in Unity, most likely at this point in time, it's still C# 9 and not C# 11 that is supported. But I cross my fingers for you that if you are watching this video in the future after it's out for 1 or 2 years, that you can already use C# 11 inside your Unity projects. Okay, but enough of this. Now I want to mention another important thing, and that is that these operators are only defined for signed and unsigned integers and longs. That means that the result is always at least 32 bits long, and if you have another data type which you want to use with this operand, then it will be automatically converted into one of these types. Okay, now before I explain you the logical bit operators, let's quickly try out an example with our right bit shift operator. Okay, let's change our data type to unsigned int, and let's change this to our right bit shift operator, and let's start, and as you can see, everything works as expected. So let's start with the logical AND operator. The logical AND operator will just compute a bitwise logical AND between 2 binary literals. So what is this doing? Basically, if the first number's last bit is a 1 and the second number's last bit is a 1 as well, then in the result, the last bit will be a 1 as well. If one of these is 0, then in the result it will be a 0 as well. And if both of them are 0, then in the result it will be as well a 0. So be careful, because I don't know why, but many beginners think it's a binary addition, okay? It's no binary addition where you have, for example, 0 plus 1 equals 1, and 1 plus 1 equals 0, but the 1 will be transferred 1 bit to the left side, okay? It's not like this. It's no binary addition, it's really just a bitwise AND computation. So this is fairly simple, right? And we continue fairly simple as well with the logical OR operator, which will just compute the bitwise logical OR between two binary literals. So 1 plus 0 is 1, 1 plus 1 is 1, and 0 plus 0 is 0. And then, of course, we also have the logical XOR operator, and we can write this like the normal XOR operator with the circumflex symbol. So remember, the XOR is exactly the same like the normal OR condition, except for 1 plus 1. So if you have 2 times 1 at the same bit position, then this will be equal to 0, but all other cases are exactly the same like the normal OR condition. And all of these bitwise operators that I showed you in this video until now, you can also just do by writing an operator and then the equals, exactly like we did this with the arithmetic operators. And then behind the equals, you will write the right side operand. Okay, so let's try this out by doing this one time with our logical AND operator and one time with the left Bitshift operator. Okay, so let's write this code, try it out, and as you can see, it works as we expected it to work. Okay, and the last thing that I want to show you is the bitwise complement operator, which will just create a bitwise complement of your operand, and to use it, just write a tilde in front of your operand. And for those of you who already know what this is and how this works, you will directly understand that you can only freely use this with a signed data type, not with an unsigned data type, and this is because it will change the positive value that you have to the negative value, and the negative value to the positive value. So for example, if you have a 6, it will change it to a -7, or if you have a -7, it will change it to a 6. In Germany, we say Zweierkomplement for that, and I think there was also another word for this in English, so please write it in the comments if you know that, but to be honest, I don't know the word in English for that exactly. I just know the bitwise complement, but I think there was a second word for that. And for those of you who don't understand what this is, maybe watch a YouTube video about this so you better understand what we are doing here. And also keep in mind that the negative number is always +1 of the positive number, because if you remember correctly, the 0 in binary is positive, it's all zeros, whereas the 1 in binary is all zeros and then the last bit is an 1, but the -1 in binary is all ones, okay? So you have one number more in the positive range. Okay, but enough of the theory, let's try it out. Let's try it with a +6. So let's write 0, 1, 1, 0. And let's execute this, and as you can see, it will be converted to a -7. And as you can see, it changed all the zeros to ones and all the ones to 0. And also, all the leading zeros that were invisible before, because they were not necessary for the number, are now visible because they turned all into ones. Okay, that's it for the video, and I see you for the next one. Welcome to the end of this video. Hit the subscribe button to stay updated. Also, if you need some high quality assets for your game or like our channel and want to support us, feel free to check out our assets at the Unity or Unreal Asset Store. You'll find the link to our store pages in the description. I hope you learned something new and see you next time.